So in this class, I will discuss about an important concept called equilibrium of bodies. So in the earlier classes, we have discussed about how to find the resultant of concurrent force system as well as non-concurrent force system, coplanar. So here we will see under what condition a body will be in equilibrium. So there are two types of equilibrium. One is static equilibrium, another one is dynamic equilibrium. A body is said to possess static equilibrium if at all it is at rest. So normally bodies will be subjected to some external forces, but even then certain reactions will be developed and those reactions will keep the body in equilibrium. That means it will be at rest only. Similarly, a body will be in uniform motion. If a body is in uniform motion, certain forces will be acting on the body, but still it will be under uniform motion. Then we say that it is also in equilibrium. So if it is at rest, it is called as static equilibrium. If it is in motion, uniform motion, it is called as dynamic equilibrium. So a body is said to be in equilibrium if and only if it is at rest or in uniform motion. So what are the different conditions of equilibrium? So normally we are going to have the resultant force, or the resultant may be a force, or it can be a couple also. We have discussed about it because the effect of a force is to translate the body or to rotate the body. So if at all the body has to be in equilibrium, that net effect of all the forces or the net effect of the resultant it should be zero on the body. So we can say the condition, general condition is resultant force on couple should be zero. That is, there should not be any, there is no translatory and rotational effect. So if the body should not move, or it should not have any translation, as well as it should not have any rotation also. So the meaning of that is your resultant force should be zero, as well as the resultant couple also should be zero. So because resultant can be in both the way, it can be a force or it can be a couple. So that's why both of them should be zero if at all we say that the body is in equilibrium. So there are two different types of force systems we have discussed. One is coplanar concurrent force system and another is coplanar non-concurrent force system. So the conditions for coplanar concurrent force system is, since the resultant should be zero, in the case of concurrent force system, you don't have the concept of moment there, because all the forces pass through a common point of concurrence, and the resultant also passes through the point of concurrence. So in such a case, only force will be there, then there is no question of moment. So the resultant force should be zero means both sigma fx and sigma fy should be zero. So algebraic sum of all the forces in x direction should be zero, and all the algebraic sum of all the forces in y direction also should be zero. Then we say that the body is in equilibrium in the case of coplanar concurrent forces. In the case of non-concurrent forces, since the lines of action of forces are not meeting at a common point, there is an effect of moment also. So rotation effect also will be there. So that's why one additional condition will come into picture here. In addition to sigma fx 0, sigma fy 0, you should have the condition of sigma m also 0. So algebraic sum of the moments of all the forces taken about any point in the plane. You have to understand that word. Any point in the plane, it should be 0. So then only we say that the body is under equilibrium under the action of coplanar non-concurrent forces. So here I have given two sketches here. So this is the case of a concurrent force system. F1, F2, F3, they are concurrent forces meeting at a common point O. O is the point of concurrence. Naturally, if you find the resultant, it will pass through the point of concurrence only. So let us take this R is acting like this. How to find its resultant? So now if you introduce a force which is equal in magnitude, E, force E, which is equal in magnitude and collinear, it should act along the same line of action but opposite. So you can see here, exactly in the opposite direction. So if this is the case, then this E is called as the equilibriant. So equilibriant is a force which is collinear, equal and opposite in nature to the equilibrium or to the resultant. That means, in other words, if resultant force is represented like this as a vector, E should be represented like this, and vice versa. E should be minus R like this, vector form. So magnitude wise they are equal. Then line of action of both resultant and equilibriant are collinear. Then sense is opposite, so it should act in the opposite direction. So this is the case of an example for coplanar concurrent force system. In the case of coplanar non-concurrent force system, you see here F1, F2, F3, F4. I have taken 4 forces here. This is non-concurrent force system. In this case, we find the resultant. It may be something like this. With respect to some point O, we can always compute the resultant by finding the R, alpha and D value. D value is this. This is your D value, perpendicular distance value. In this case also, equilibriant is a force which is equal in magnitude to R, acting in opposite direction and also collinear. So see here, the effect of this R, the effect of this resultant R about the point O is clockwise. Moment due to this R about the point O is clockwise, whereas moment due to this E, equilibriant force about this point O is anti-clockwise. But both magnitude wise they are equal. The moment of this will be R into D, whereas the moment of this will be E into D, or it is R into D only. So only thing is it gives an anti-clockwise moment, it gives a clockwise moment. So that is very important. In the case of a non-concurrent force system, it can have an effect like this. If the moment due to resultant force is clockwise about some point, the moment due to equilibriant will be anti-clockwise about the same point whose magnitude is equal to the resultant. So this is what a very important thing. So in the case of concurrent force system, you need not have the concept of moment, whereas in the case of non-concurrent force system, 3 conditions, sigma Fx0, sigma Fy0, sigma m0, 3 conditions should be used. In the case of concurrent force system, only 2 conditions. So related to only forces, in addition to 2 conditions of forces, you have 1 condition of moment also. So this is about equilibrium of force system. Now suppose sometimes this resultant may be a couple. It is a couple. Then also E is also a couple. Equilibrium is also a couple whose magnitude is equal to R, but acting in opposite sides. That is very important. That means, for example, if R is a couple like this, resultant is a couple like this, clockwise, this equilibriant is a couple in the anti-clockwise sense, whose magnitude is equal to R. If this is 100 Newton meter, this also is 100 Newton meter. If this is clockwise, this will be anti-clockwise. If this is anti-clockwise, this will be clockwise. That's all. Okay? So this is the meaning of equilibriant. So in any problem, if they ask you to find the equilibriant, please note the point here. If they ask you to find the equilibriant, what you have to do is you have to find the resultant as usual, whether it is concurrent or non-concurrent. You have to find out the resultant, which I have explained in the earlier classes, same procedure, but you have to take the equilibriant acting in the opposite direction of the resultant, collinear and equal. That's all. So procedure is same. One last step, extra step is you have to show the equilibriant in the opposite direction of this R, whose magnitude is equal to R, and it should be collinear. So 3 things are important. So collinear, equal and opposite to R. That is the meaning. Now there is one important theorem called Lami's theorem for this equilibrium. To analyze problems on equilibrium of bodies, this Lami's theorem is a very simple rule. So developed by Lami. So it states that if a body is in equilibrium under the action of 3 forces, please note that this Lami's theorem is applicable only if the number of forces is restricted to 3. If it is more than 3 or less than 3, then we cannot use Lami's theorem. That is very important. So it is only subject to 3 forces. Each force is proportional to sine of the angle between the other 2 forces. Please understand the wordings here. I will take 3 forces, concurrent forces like this. F1, F2, F3 are the 3 forces meeting at point O. Then, according to this theorem, he says that if at all the body is in equilibrium, If at all the body is in equilibrium under the action of these three forces, each force is proportional to sine of the angle between the other two forces. So for example, I will take F1 force. F1 force is proportional to sine of the angle between the other two. So I will take the angles like this. Alpha is the angle between F2 and F3, beta is the angle between F1 and F3, gamma is the angle between F1 and F2. So if I take like this, so according to this statement, F1 is directly proportional to the angle between the other two will be alpha, therefore F1 is directly proportional to sine alpha. Then F2 is directly proportional to sine of the angle between the other two forces, means between the other two forces the angle is beta, so F2 is directly proportional to sine beta. Then F3 should be directly proportional to sine of the angle between the other two, means angle between F1 and F2 is gamma, so F3 is directly proportional to sine gamma. So this is the statement of Lami's theorem. If at all a body is in equilibrium, so this is the body considered. If at all the body is in equilibrium, this under the action of three forces F1, F2, F3, this is the equation that we can have. Now very simple proof for this. So what I do here is, this is the diagram given. Now I will construct a polygon using this force polygon using this diagram. How to construct a force polygon is, you take the first force. So O, F1 is the first force, it starts from here. So what I do here is, I will take this as OA. So I will draw a line in the direction of F1. So start from point A, draw a line in the direction of F1. So it will be, this angles will be knowing. So with that angle, you have draw the line with respect to horizontal, you will be knowing the angle. So just draw that line. So OA represents this F1. Then from the point A, draw a line parallel to F2. So F2 I have drawn like this. After F1 I have taken F2. So I draw a line parallel to F2 like this. So this AB represents F2. Then draw a line parallel to F3 from this point, from the point B. So BO will represent F3. So it all depends on the magnitude. So you to some scale you can draw. So once you draw this force polygon, it's a triangle here because there are only three forces. If you take four forces, then it will be a quadrilateral. If you take five forces, it will be a pentagon like that. So in this case, you can observe that if at all the body is in equilibrium, this triangle, this polygon will close. That means this OAB becomes a closed triangle. So if this is the case, I have shown the arrows here. First you have to draw F1, OA parallel to F1, then AB parallel to F2, then BO parallel to F3. Now once you draw the triangle, now you can see here the angle between F1 and F2, F2 and F3 is alpha. So the angle between F2 and F3, see this is F2, this is F3. So these are the lines of action. Just produce this F3. So this angle should be alpha. So the angle between F2 and F3 extended, this is alpha. Then the angle between F1 and F3. F1 and F3 means this. F1 and F3 means this. So just produce this F1 like this. So this angle between F1 and F3, it is beta. You can see here, it is beta. Then the angle between F1 and F2 is gamma. So F1 and F2 means this, you produce this F2. So the angle between these two becomes gamma. So now you know exterior angles. These are called as exterior angles. So alpha, beta, gamma, they are the corresponding exterior angles. Now you can calculate the interior angles. Interior angles of this triangle will be 180 minus 360. Because these two, if you add, you get 180 right line. Similarly, interior angle here is 180 minus beta. Interior angle here is 180 minus gamma. Now, according to trigonometry, you have sine rule. So you have sine rule in trigonometry, which you have studied in your mathematics in your earlier classes. According to that, in any triangle, it is like it states like sine rule states like this. If A, B, C, they are the sides, small a, b, c are the sides, and capital A, B, C are the respective opposite angles like this. So opposite to A is this angle, opposite to B is this angle, opposite to C is this angle. So if this is the case, then as per sine rule you have A by sin A is equal to B by sin B is equal to C by sin C. So this is sine rule. So this we can apply here. So here the interior angles, as we know, this ABC will be now 180 minus alpha, 180 minus beta, 180 minus gamma. They are the angles now. Corresponding sides are F1, F2, F3. They are the sides, magnitudes of the forces are the sides. Now if you apply that, I will take this OA. So OA divided by sine of the angle opposite angle. Opposite angle is sine of 180 minus alpha. You just compare these two. It should be equal to second side is AB. AB divided by sine of the opposite angle is 180 minus beta. So AB by sine of 180 minus beta is equal to third side is BO. BO divided by sine of the angle 180 minus gamma. Now you know the ratios. Sine 180 minus alpha is sine alpha, sine 180 minus beta is sine beta, sine 180 minus gamma is sine gamma. Since all these ratios are equal, it can be taken equal to a constant k. Now here also, if you replace this, that whatever variation symbol by a equation, so f1 is equal to k into sin alpha. Like that it will come. Okay. Similarly, f2 is equal to k into sin beta. f3 is equal to k into sin gamma. So then you can write in this fashion. So f1 by sin alpha is equal to f2 by sin beta is equal to f3 by sin gamma is equal to k. So this is called as the Lami's theorem. So state and prove Lami's theorem is asked. So you have to write the statement, and proof is very simple. Only 3-4 stages. You will get the proof. So what we have done is we have considered only 3 forces. So please note that Lami's theorem, Lami's principle can be used to solve problems with only 3 forces. When 3 forces are acting on a body, this can be used. When more than 3 forces are acting, then you can directly use these equations. Sigma Fx 0, sigma Fy 0. Otherwise, only 3 forces are there. Either you can solve using these 2 equations, or you can use Lami's equation. So please observe here, in the case of Lami's equation, so if you know any 2 angles here, suppose if you know alpha and beta, gamma is automatically known because alpha plus beta plus gamma is equal to 360 degrees. So this is 360 degrees. If they give any 2 angles, you can find out the third angle. And the thing is, if you know only one force, you can find out the other 2 forces. So out of 3 forces, if you know only one force, the other 2 forces can be found out using Lami's theorem. So because you have 3 forces here, and you know if you know only 2 angles, the third angle is automatically 360 minus of the sum of the 2 angles. You can directly use here and find out the unknown forces. So in the case of coplanar concurrent forces, you have 2 equations of equilibrium, sigma Fx 0, sigma Fy 0. In the case of coplanar non-concurrent force system, you have 3 equations of equilibrium, sigma Fx 0, sigma Fy 0, and sigma m 0.